Good morning, ma'am.
Sir, good morning, sir.
Yes, so
Sir, just 1 minute, sir.
sure, no
We'll start.
problem. Just
I'm
let
going
me know when
forward.
to start.
Yeah. Sir, 1 minute, sir. Sir, sir, good afternoon, sir, and good afternoon, participants.
Good
Sir,
afternoon.
sorry for the delay, sir. Actually, some technical issue, so that's why I had taken 3 to 4 minutes of time. Sorry for that. Yeah,
No
sir, shall
problem.
we start, sir? Shall I
Yeah, sure.
start? Yeah.
Yeah.
Sir, yeah, good afternoon, participants. So, myself, Dr. Varlakshmi from JNTUA School of Management Studies. Today, we have Dr. Anshuman Kallagaru as a resource person for delivering his lecture on blockchain ecosystem. So, we are very glad to have you here today, sir. So before going to start the session, I want to go for a brief introduction of today's resource person, Dr. Anshuman Kallagaru. Sir, can I, sir? Can I proceed?
Yes, ma'am, please do.
Yeah. Yeah. It's my pleasure to read the profile of Dr. Anshuman Kallagaru, who is working as a postdoctoral visiting researcher at Center for Wireless Communications, University of Oulu, Finland, under the supervision of Professor Micah Ilantio. Before that, Sir has worked as an associate professor at the Department of Computer and Communication Engineering, School of Computer and Information Technology, Manipal University, Jaipur, Rajasthan. Sir has earned PhD from JNU in 2017 and Master UBNet from University of Nice Sofia Antipolis, France in 2011, and Master of Science in the area of telecommunication and wireless networking from ISEP University Paris and France in 2008. And Sir has graduated as an engineer from Rajasthan University, and Sir completed 2 internships. First is Alcatel-Lucent Paris under supervision of Mr. Jerome Broch, Public Safety Director during the 2007 to 8. And the second one, the second internship, which is in Orange Labs, Sofia Antipolis, France, under the supervision of Dr. Patrick Brown, Senior Research Expert during 2011. And Sir, areas of interest are blockchain, information-centric networking, software-defined networking, and Internet of Things. Sir has liked to search for technical solutions for day-to-day problems which would affect people at large. And Sir is open for research-based collaborative work, and Sir is very much interested in the blockchain area, so that we scrutinize the profile of Dr. Anshuman Kallagaru for being a resource person for FDP program and application of emerging technologies. And Sir has delivered so many lectures on IoT and blockchain also. Sir, we welcome you to the FDP program on application of emerging technologies in business, which is organized by JNTUA School of Management Studies and the team. Sir, we welcome you, sir, with great honor. Thank you, sir.
Thank you for such a beautiful introduction. Thank you.
So now we can start the session. Sir.
Okay, great. All right.
Thank you, sir. Thank you very much.
Thank you. So are the slides visible?
Yes, sir.
Okay,
It's
great.
visible.
Perfect. Right. All right. So thank you everyone for inviting me, and I hope you will have a fruitful learning session, and I too will have reciprocatory learning from you all as well. Okay, so so today's topic, the session that I'm going to deliver on, is a blockchain ecosystem, right? And this is very interesting. At the same time, it is very delicate topic to deal with, because there is so much of hype in this area, and there are things which are on the evolution, right? So things are still not settled down. So the blockchain itself, the technology itself, is evolving every now and then, and it has not yet taken any mature form. The only prominent use cases that we see, which have kind of closed down to maturity, or you can say that the use of blockchain technology in cryptocurrency is very much popular, from which it actually evolved. But having said that, it doesn't mean that things are not getting developed. So every now and then you see like application of blockchain technology in different domains, right? So today's topic, I believe, would be interesting because it talks about the ecosystem, right? The entire system, and what are different actors and the players and how they interact with each other and things like that, right? So I hope it would be fruitful for you all. And with that, let me just start the session then. So the way I've planned the session is that we will have two parts. What first part would be dealing with blockchain technology, where we are going to quickly look at what is blockchain technology, what are its benefits, how and why it came into picture, what were the problems and what are the advantages of the blockchain technology, and then we'll talk about what are the characteristics, the intrinsic characteristics of the blockchain technology, and then of course the smart contract, which is the most prominent application of blockchain technology, and which has kind of revolutionized the space in which blockchain technology can play a cardinal role, right? So this would be the first part, which we'll try to go very quick over it, because I believe you had already a bit of introduction of blockchain technology and the space and the domains in which it can be leveraged, right? The second part, which would be a little more different than what you might have learned so far, is going to be a blockchain ecosystem, where, as I said, there are various roles which are distinguishable from each other, and their actors, and how and what they offer in terms of functionalities, and how they interact with each other, and how the entire ecosystem is working, so that it can be leveraged, and you can have maximum gain out of it, right? All right, so let's get started. So let's quickly go over with the blockchain technology, right? And its use and its applications and its features, right? So before blockchain technology, the systems were traditional and they were centralized systems, right? So most of the business processes and computing facilities are implemented as centralized systems, before blockchain. I mean, still they are, but still, but we are talking about the time which was before 2008, So all the business processes, they were kind of implemented in a centralized way, and such systems have evolved over the years, and these centralized systems are mature by now. They offer numerous advantages like high physical security, since they are housed at one fixed location. You don't need to have a multiple infrastructure facility which needs to be deployed in different regions. You can have one centralized facility. Then they are easy to monitor and maintain, and controllability is very high in such systems. Of course, what is very important is that for such systems, you have established legal frameworks in terms of making audit and making sure that these systems are in compliance with these legal frameworks, right? Also, they support the centralized market, so as the business world needs the systems, these centralized systems are backing them up and supporting them, right? So these are the advantages that are there for centralized systems. However, there are numerous inherent issues with such centralized systems, right? For instance, third-party intermediary, right? It stands like an authoritative entity between the transacting peers, right? And every intermediary is going to charge some operational fee, which adds to the total fee, right? So if, for example, I am transacting with, let's say, someone sitting in, let's say in some part of the world, let's say in Canada, then probably I have to go through multiple intermediaries. Usually it is around 4 to 5 at least intermediaries, and every intermediary is going to charge some fee. So there is a significant, though not much, but there is some significant amount of fee that that we as a user have to bear and pay, right? Also, every intermediary is going to add its own processing time, which inflates the overall delay and also leads to a privacy issue, right? Also, moreover, these systems are centralized in nature, which means once the user put their data, they lose the control and the ownership of their data. Right? Once I put my data on a centralized system, of course I can access it, but I don't know who else is accessing it. So this is very important that you host your data somewhere on the server, but at the same time you should have an ownership of your data, which is not there in the centralized system. Further, being centralized, they have a central point of failure. Once if by any reason, by an attack or due to any system failure, if these systems they go down, then then there's no backup, because these are designed in this way that there's just one central massive facility which is serving all its users, right? So they are central point of failure, and this is important from the attack point of view. Of course, if the system is a centralized, right, you can put as much security features on top of it so that it is entirely secure. But the point is, if somebody penetrates in, if an attacker or an intruder manages to penetrate in, then it's all lost, because it's everything is there in one centralized place and everything is lost, right? So that's a problem. Also, there is a problem of transparency. I don't know who has looked on my account and who has seen the data, which actually is very personal to me. So transparency is not there, right? Somebody else is managing my data or managing my let's say my money on behalf of me. So it lacks transparency, right? Also, the services may not be available due to downtime. You must have seen, like, when at times, let's take an example of a banking facility. When they have maintenance going on, they would display a flash message saying that the service has gone down, and you won't be able to access this facility for so and so time. So there's a problem of a downtime associated with such centralized systems, because there is no other backup, and there is no distributed facility. The facility is not decentralized, it is just housed in one central location, right? And also, such systems they lack autonomy, in the sense that nothing can be of course something can, you can schedule a transaction, but that's not is autonomy. When you make a system autonomous, everything is done based upon what you have coded in terms of software, and when certain conditions they meet, of course things get triggered, and everything gets settled down the way you want, right? So that level of autonomy is not present in such traditional centralized systems, right? So I gave you an idea of what are the benefits of the centralized system, but at the same time there are a lot of problems that have come over the years with such centralized systems, right? And these problems can be all easily mitigated with the use of distributed ledger technology, right? DLT. So what is DLT? So there is no standardized definition till this point, which can be used to define DLT. But I like the one which has been put forward by Financial Conduct Authority, FCA UK, right? According to this, DLT is a set of technological solutions that enables single sequence, standardized, and cryptographically secure records of activity. That is digital ledger, right? Which is safely distributed and acted upon by the network of varied participants, right? Participants means the miners, the nodes which are putting their mining facility and the hashing facility, right? So at the core of the DLT of distributed ledger technology is basically a digital ledger, right? That is distributed across all the nodes in a decentralized peer-to-peer network. All right. So that's the crux. So core of the DLT is actually a digital ledger that is distributed. So everybody has exactly same copy of the database, that is digital ledger, and it's distributed, right? And some of the important characteristics of distributed digital ledger are they are immutable, shared, synchronized, and cryptographically sealed. right? Of course, over the years, if somebody has already heard about blockchain, and there are attacks that have happened on such, distributed ledger applications, right? And DLT based applications or blockchain based applications. So people these days have kind of, fine tuned this definition. They say that it is not probably absolutely correct to say that it is immutable, because there are different kind of attacks that have happened over the years. For example, 51% attack, which says that if some people, they collude and they collaborate, of let's say 50% of the mining facility, they collaborate with each other, and then they are able to actually temper or manipulate the data, that is the digital ledger, right? So they say that instead of saying immutable, it is better to say that it is you have proof of immutability, right? So that's a little distinction here, because there are instances that have happened where the data has been manipulated or mutated, right, or altered. So but the best thing is that even if this kind of alteration is happening, then you are able to have the logs and the records of that, and then you can see what went wrong, and probably if required you can recover your system from that point of failure, right, or from that point of a malicious attack, right? All right, so this is what is DLT. So DLT talks about, so it's important, I think, to even repeat this thing, is that DLT says that it's a system that is decentralized, that has a distributed digital ledger, which is kind of having characteristic like immutability, shared, synchronized, and cryptographically sealed. But it doesn't talk about the structure of the digital ledger, how this digital ledger is actually created, and it is like kind of increased, or you can say it kinds of keeps on appending to it. It doesn't talk about the data structure, right? So that's what is the DLT. So DLT is a big umbrella under which there are different technologies which have evolved, and one of the most popular technology, or one of the most popular type of DLT, distributed ledger technology, is blockchain, right? So at times people say that is DLT and blockchain same? Of course not. There are other technologies that comes under the umbrella of DLT, which are, for example, direct acyclic graph, or let's say hash graph, or there are others as well, right? But blockchain is the most popular, and it has been so much popular over the years that it is now synonymously being used for DLT and blockchain. People say blockchain oblique DLT, right? All right, so having said that, what is blockchain? Is it a data structure? Is it a technology? So in fact, there is no one way to define a blockchain technology precisely. There are different viewpoints based on which you can define what is blockchain. One way to define blockchain is that it's a type of a distributed ledger technology, as I just now mentioned. So what is ledger? So ledger is a kind of a structure, right, or a file that holds all the transactions that have occurred in the past. In distributed ledger technology, this ledger is going to be distributed among different nodes of the blockchain network. Of course, the security is of paramount importance here. When the ledger is distributed, meaning that all the nodes have a local copy of the database, then it is important that since it is distributed and shared with all the nodes, at times you don't know the nodes. We'll see like different kind of blockchains where public and private are there. But most of the time, if you talk about, let's say, public blockchain, then you don't know that who are the nodes which are participating and are forming a part of the blockchain peer-to-peer network, right? So security is of paramount importance here, because the data is not centrally located. It is with every node in the network, and they all have exactly the same copy of the ledger, right? So this is one way of specifying blockchain or defining blockchain, that it is a type of a distributed ledger technology. second way to define blockchain is from data structure point of view, which comes from the word blockchain itself. So I think it's interesting to mention here that blockchain, as you must have all learned by now, it came with the advent of the cryptocurrency Bitcoin, right? And the white paper that was written by a pseudonym called as Satoshi Nakamoto. Till date, we have no perfect knowledge of who this person is, whether it is he or she, or it's a group, or it's a company. We don't know, right? So point is that in that paper, when Bitcoin was introduced, right? There was no mention. There was nowhere mentioning of the word blockchain. What was mentioned is blocks in chain, and later on, why after 2008, people started talking about blockchain. So blocks in chain, then it became as blockchain, right? So we can still break down the word into two, block and chain, right? So the transactions which are valid and occurs during a particular time duration are all bundled up together and cryptographically sealed in a single unit called block, right? So blockchain, block and chain. So what is block? So block is a unit that actually is representing all the transactions that have occurred in a definite time duration, right? Now these blocks, they are created as the transactions are or as the transactions are made by the users of the blockchain system, right? So you have one block, let's say, which is holding about 10 transactions, then 11 new transactions come into the space. They are all bundled up and the new block is created. So these blocks are then logically connected with each other using a chain, and this chain is actually a logical hash-based chain, right? It's a cryptographic chain where what happens is the hash of the previous block is stored in the current block. So let's say 5 minutes before a block was created, and after 5 minutes, what all transactions have occurred, they are all clubbed together and a new block is created. So after 5 minutes, a new block is created. This new block is then connected with the previous block such that the previous block's hash is stored in this current block's header, right? So block contains header and the rest part, which is actually all the transactions. So in the header, one of the field is the previous block hash, right? So that's how it is called as block and chain. So these all blocks are chained together, or they are logically linked together using hashes, right? So current block holds the hash of the previous block, and when the new block will come, that block will hold the hash of this current block, and it keeps on growing in a append mode, exclusive append mode. All right. So that's one way. So DLT doesn't talk about this structure. That's a distinction. DLT says there has to be a distributed ledger which has to be shared with all the nodes. But what is the structure of this digital ledger? It doesn't talk about that. Blockchain says that this is the way to create the structure. So transactions occurring in a particular duration of time, bundling together, creating a block, sealing it cryptographically. Another block comes up, it takes the hash of this block, stores the field. That's how the entire thing is connected, right? And if you make a change just by 1 bit, so if let's say there's a block of, let's say 100 megabyte, and if you're going to change just 1 bit, everything is going to collapse because everything is linked together. I think it falls beyond the scope of my discussion that how it is connected. Of course, there's a Merkle tree which is connected with which is created by connecting together all these transactions, and then the root of the Merkle tree is put in the header, and the entire hash is created, and you compute nonce and things like that, right? So this is what is the another way of understanding what is blockchain. And the third way of explaining blockchain is from the technological point of view, because usually we say blockchain technology, and at times we say blockchain as well, right? So from the technological viewpoint, blockchain is often called as blockchain technology, right? So it's a powerful and profitable amalgamation of underlying technologies, concepts, and algorithms, right? For instance, blockchain intensively makes use of a lot of cryptographic techniques like PKI, public key infrastructure, hashing, digital signature, Merkle tree, time stamping, etc. Right? Also, blockchain utilizes peer-to-peer networking technology to build decentralized blockchain network. Right? Also, blockchain is heavily dependent on something which is called as consensus algorithm and economic models to have, to provide incentive to the miners who are putting in their a massive computing facility, right? So these are different viewpoints based on which you can explain and define what is blockchain technology, because so far there is no standardized definition. All right. Okay, so what are the different types of blockchain? Quickly, I'll go over it. I won't take much of time here. So basically, there are 4 different types of blockchain, right? Public, private, permissionless, and permission. The difference is very delicate and at times very overlapping, right? So it kinds of overlap at times. In public blockchain, copies of the digital ledger is distributed and maintained over public servers, which are not under the control of any single authority. And such blockchain tends to be open system, right? In opposed to that, in private blockchain, the ledger is hosted at private servers which are not in public domain, forming a kind of a closed system, right? On the other hand, the difference between a permissionless and permission blockchain is based on who is allowed to perform read and write operation in blockchain, right? In permissionless, any node with the computing facility can join the peer-to-peer decentralized blockchain network. That is, no permission is required, and all the nodes who have joined the network are allowed to perform read and write operation. It means any node can create a new content, that is new block, and write this content to existing blockchain, right? In an exclusive, of course, append mode. So you cannot write anywhere in between the blockchain. You can just write at the end of the blockchain, which is always in append mode, right? On the contrary, in the permission blockchain, nodes need permission to join the network. So here there is probably a consortium of nodes, or there is one couple of nodes, or just one single authority which will actually allow nodes to enter and join the network, right? So this is kind of permission blockchain system, and all the existing node within the network are allowed to do the read operation. However, only very few selected nodes are allowed to perform write operation, of course, in exclusive append mode, right? So so this actually leads to different types of blockchain, and it all depends upon which kind of domain you are making use of blockchain technology, and accordingly you will have either public permissionless blockchain, or let's say private permission blockchain, right? In public permissionless blockchain, there is a lot of transparency, and anybody can join, anybody can write, and anybody can read, so that's more open system. They are more transparent, but there is the privacy is traded off there, right? It has less privacy there. On the other hand, if there is private permission blockchain, then you will have a control over who is joining and who is participating and who is actually doing the right operation, and because of that, here there is less transparency, because who has joined the system, who are participating. So here there is a transparency is less, but here the privacy is very high, right? So it depends upon what kind of application you are making use of blockchain technology. All right. Okay, so quickly we'll go over the smart contract. So what is a smart contract? So this is one of the most utilized application of the blockchain technology in the current times, right? And interestingly, the smart contracts didn't come after blockchain technology. It was proposed long before 2008. It was proposed by Nick Szabo in the year 1994. And the idea is, that you have a computer program where you can encode all the agreements and terms and conditions between the two parties which are trying to perform any operation, and then run this program on the top of the blockchain technology, right? So basically, it's a softwarized agreement. So what is smart contract? Kind of a softwarized agreement. All the legal agreements, they need to be put in terms of software codes and put on top of blockchain. And these are self-executing codes, which means that once a predefined state reaches, these smart contracts are triggered and they are executed by itself, and they do whatever task you want the system to do, right? So that's how you have autonomy in such systems, right? So two interesting features I would like to mention here of smart contracts are immutability of codes and transparency, right? Immutability of code implies once the smart contract is deployed on the blockchain, it cannot be altered. That is, it can neither be breached nor be amended, right? However, of course, if required, it can be updated upon the agreements of the nodes in the network, right? So if everybody agrees and the nodes in the network agrees, you can, of course, update the smart contracts, right? Such kind of transparent and traceable execution of logic, right, builds trust among the users, because everybody knows that this is kind of a code. Everybody can have a look at the code, and they know what terms and conditions are encoded in that softwarized agreement, and that's how everybody can trust, because these smart contracts, once they are deployed, it cannot be changed or amended or altered. And that's how it brings the trust among the users in the blockchainized systems. All right. And the blockchain has thus lead to autonomy, and it allows you to create a decentralized application instead of web applications, which are basically centralized applications, right? So having said that, let's quickly look what are the salient features of the blockchain, right? So the first and the most important one is the decentralization, right? So decentralization with peer-to-peer overlay networks and distributed copy of digital ledger has actually changed the entire way the business processes can be implemented, right? Also, the decentralization ensures no central control, which implies any node in the network can create new content that is blocked and send it to other nodes, and they can in turn verify and append it to their existing blockchain or database or digital ledger, right? So enhanced security comes from the underlying cryptographic techniques, which I just now mentioned, right? Immutability is of course one of the intrinsic feature. Once you put the data, everybody has the copy of the digital ledger, and if somebody tries to change it, other copies would say no, it's not correct, right? So that's how you build immutability. Transparency with anonymity. So this is very interesting, because the blockchain says that everybody can look into the blockchain and see that I'm talking about public blockchain system. So everybody can look into the system and see that there has been a transaction that has just now taken place from this address to this address. However, you don't know this address belongs to whom. So you don't know who is the owner of this address. So it provides transparency. At the same time, it provides pseudo-anonymity. Pseudonymity comes from the fact that the link between the address, the addresses in the blockchain system and the physical world, who is the owner of this address, you don't know that, right? So it provides both at the same time, interestingly. Of course, as I said that in the centralized system, every entity is going to add its own processing delay. Here, the processing time is very, very less, because there is no central intermediary, and anyone who mines the block for the first time, that moment the first miner mines a new block, it gets confirmed, right? Non-repudiation is very very important characteristics of very important characteristic of blockchain. It says that once you make a transaction and it gets logged in the system, in the blockchain system, you cannot say tomorrow that I didn't do it, because it carries your digital signature. So you cannot deny once you have committed or once you have initiated a transaction. All right. Also, there is a consensus-based validation. It's not so that one powerful mining facility will come and it will just try to do everything on its own. Of course, there has to be a consensus established in the system. Only then you can add new content to the blockchain, right? And also, a smart contract-based automation is one of the biggest kind of breakthrough which has helped business operations and business processes to make use of blockchain technology. All right. Okay, so with this, we come to the end of the first part, which is blockchain technology and DLT and its features and advantages and all. And now we move towards blockchain ecosystem, right? So, what is blockchain ecosystem? What are the different actors? What are their roles? How they interact with each other? So instead of talking here about blockchain ecosystem for a specific region, you would see, if you try to go and check out books and literatures and research papers, you would see that every country or every continent is coming up with their own blockchain ecosystem. But here I'm not. I would not be talking about a specific blockchain ecosystem, right? So I would talk about here rather about generic blockchain ecosystem, right? Based on this interesting paper, which is titled as the generic blockchain ecosystem and its strategic implications by Ria Sano and all. All right. So there are total 11 distinguishable roles that have been identified in a generic blockchain ecosystem, right? These roles are as shown. Of course, they all work in a collaborative way to establish the entire ecosystem. We'll briefly talk about each of them as in our next slides. All right. Starting with the first one is the consumers, right? So consumers are the ones who request and who make use of blockchain-based applications, right? Now, based on their needs, they can ask for either on-chain or off-chain or hybrid decentralized application, right? DApp, which is acronymed as decentralized application, is acronymed as DApp, right? So on-chain and off-chain are two different approaches. Of course, there are hybrid approaches, which clubs together the two. But on-chain basically is in on-chain, everything is stored on the blockchain itself, right? When I say everything, it means the transactions and the assets of value, they are stored on the blockchain itself, right? So on-chain application are storage intensive, as everything is going to be stored on the distributed ledger itself, right? Whereas in off-chain, the digital assets of value, they are moved or transacted off the blockchain. That means not everything is put on the blockchain. What is put on the blockchain are their fingerprints, right? So for an example, I can transact a document to some other party, right, of the blockchain. And when I make a transaction, when I share it with someone, and the hash of that document can be put on the blockchain. So the actual data is not put on the blockchain. Their fingerprints in some way are put on the blockchain. And later on, if anybody kinds of altered that data, you can always match. You can recompute the hash of that document and match with the hash which is there on the blockchain. And if there is a discrepancy, you know that something has been done or some manipulation has been done. So you can discard that data, right? So that's what is blockchain. That's what is off-chain approach, right? And they are recently very, very popular, and people are making use of it because they are less storage intensive, and at the same time they allow the way to have marriage of what existing system is there with the blockchain system, right? So there are two ways actually, the way you can create a blockchainized system in your existing organization. One is a clean slate approach, where you just rip off or you just remove the existing system and then you bring in the blockchain system, right? Another is an incremental way of deploying blockchain system, where you have your existing system and then you kind of integrate it with the blockchain system, right? So I believe off-chain system helps you to do this kind of easy and incremental integration of existing business systems with the blockchain system, right? All right. Also, I mean, these consumers, these consumers are, as I just now mentioned, they're the users or the requesters of the blockchain application. But at the same time, uh, when they participate as a miner in the blockchain network, they will get the rewards. So in a way, the participants of the network can also be considered as a consumer, because they are consuming the rewards after getting after mining a successful block, right? Also, the investors can be consumers, so they would invest in the blockchain system, get a blockchainized application, and then then give to their customers this application, and and then consume on top of that, right? So that's another way of understanding what a consumer can be. So there are three different viewpoints. Of course, the most dominant one is the most evident one, I would say, not dominant. Evident one is the user of the blockchain-based application, right? So next interesting role is a blockchain infrastructure provider, right? So it is actually a massive computing facility which are provided to the users as well as developers, right? So all this massive computing mining facility is provided provided as a facility, as an infrastructure to the developers and to the users, right? Who are willing to actually build a decentralized application on top of blockchain infrastructure facility. So what they offer? So they offer a DLT framework. They specify rules. They specify block size, the consensus algorithm, etc. Right? And there are numerous big players in this space, right? Of course, the Bitcoin infrastructure is the oldest and the most dominant one. But there are others which are catching up lately. For example, Ethereum, which you can see on the right side, just below the blockchain logo. So that that kind of an I don't know, like mathematical hedron or something, which is just below the I don't know whether you're able to see my pointer or not, but so Ethereum is another big player. Which is acting as a blockchain infrastructure provider. It was actually founded by a very young researcher and an entrepreneur in the year 2014, and the name of the person is Vitalik, right? And it is one of the most popular and open source public blockchain platform that supports smart contracts. If I remember correctly, Bitcoin doesn't support smart contracts, right? So Ethereum for the first time came up with this idea of supporting smart contracts on top of blockchain infrastructure, right? Also, it is the second largest cryptocurrency platform after Bitcoin. And here in Ethereum, Ether is the default cryptocurrency provided by the Ethereum. And the Solidity and Viper are the two different languages that have that can be used to create a decentralized application over Ethereum, right? So before Solidity was the language which was used, but I think very recently Viper has been introduced. I would say like recently is like maybe two years before something. So Ethereum is the interesting player in this space. Another one is, of course, Hyperledger, if you have heard about. So initially it started as a project by the Linux Foundation, and has been later it was joined by the companies like IBM, Intel, Cisco, and many more. You can Google it and you'll find much more interesting facts about it. One of the popular framework under this grand project is Hyperledger Fabric, right? So Hyperledger is basically the entire space, and Hyperledger is the kind of a big umbrella under which Hyperledger Fabric is a big project which has been launched by IBM, right? And it's basically permissioned blockchain, right? So Hyperledger Fabric supports smart contracts, and these smart contracts are called as chain codes in Hyperledger Fabric. And languages like Go, Java, and JavaScripts are used for writing smart contracts, right? Another one is Big Chain DB, which is a blockchain database, right? It was released in the year 2016. The idea is is to combine the properties of blockchain and database world, right? So database world is kind of mature and it has evolved over the years. So the idea is to combine the two. And interestingly, MongoDB and BigchainDB have collaborated to offer the salient features of blockchain, like decentralized application, decentralization, immutability, etc., on top of MongoDB, which is a mature technology, right? And of course, there are others like Corda and all, right? Okay, so moving forward, the next important actor or in this blockchain ecosystem is blockchain platform provider, right? So these so if you see here, so blockchain infrastructure provider provides the infrastructure facility, right? And on top of that, what they create is a blockchain platform provider, right? So that runs on the top of a blockchain infrastructure provider, and the idea is to extend the facility of blockchain infrastructure provider by creating an environment that comprises of software, APIs, and services, right? So it is kind of extending and making the facility of the blockchain infrastructure provider easily accessible to the users of the infrastructure provider, right? So one more time, so blockchain platform provider extends the facility of blockchain infrastructure provider, and it comprises of softwares and APIs and services that developers can make use of, right? And it allows the development, execution, of course, testing and validation of all the applications, right? So application providers can create applications by leveraging softwares, APIs, and services offered by blockchain platform providers. And once they create an application, they can test and execute and deploy these applications, right? So this leads to the idea of BaaS, which is blockchain as service. All right. So that's what is blockchain platform providers. Just to remember, the crux is that it extends the facility of infrastructure providers by providing or by creating an environment that comprises of software, APIs, and services, right? And then using these facilities or these offerings of blockchain platform provider, there are blockchain application providers, right? And the job of blockchain application provider is to create decentralized application, DApps, right? And it is interesting to mention here is that the decentralized application has a decentralized backend. As I mentioned before, the traditional web applications, they will have the backend, which is actually a centralized server which is hosting this application, whereas in a decentralized application, the backend comprises of smart contracts which runs on top of the decentralized peer-to-peer network, right? And the front end, of course, can run on the device itself, but lately people have also tried to make the front end also stored on the decentralized servers, right? So once these decentralized applications are deployed, they can be accessed via internet, right? And they create a peer-to-peer marketplace. And most of the blockchain application providers, they provide wallets to its users, right? And it helps in easy hosting of their applications. It helps in resource management, monitoring whether the application is behaving in the a particular way or not, and it also helps in the smooth operation, right? The two important the two interesting players in this space are data broker decentralized autonomous organization, DAO, which is a first decentralized marketplace which allows owners of the Internet of Things IoT sensor data to sell their data to third parties, right? Whereas the another example of blockchain application provider is Powerledger, which is I believe is an Australian venture and is a blockchain enabled software platform which is offering a peer-to-peer marketplace for renewable energy and environmental commodities, right? Another very interesting kind of role that exists in blockchain ecosystem is miner, which you might have heard about before, but there are mining pools, right? So miners are basically these massive computing facility or hashing facility, right? Whose job is to validate and verify the transaction. Here there are two words which are being used, validate and verify. So here the idea is, when I make a transaction as a user of a blockchain system, then the system should verify whether I am a legitimate user, or am I an authentic user to make a transaction or not. So the first thing the miners do is to validate whether the user is authentic or not. And once the user is validated, the next thing to do is to verify the transaction, right? So for example, I'm trying to send, let's say, about 2 Bitcoin, to someone sitting in, let's say, France. Then the important thing is that somebody has to make sure that I at least have 2 Bitcoins in my account so that I can make this transaction, right? So verifying is to make sure that whether to look into my history and check whether I have that much amount of digital value which I am willing to transact with me or not, right? So validate and you verify the transaction. That's what is the job of the miner. So every transaction that is pushed into the blockchain system is first validated and then verified, and then all these transactions are put in a pool of unconfirmed transactions, right? Because the miner has yet to club all these transactions and create a block, right? So the next thing it does, it creates a block of a transaction based on the consensus algorithm, right? So there are different types of consensus algorithms. So just to give you an example, for instance, just to mention, proof of work is there, then proof of authority is there, then proof of stake is there, delegated proof of stake is there, proof of burn, and there are several other consensus algorithms that exist, right? And and these facilities are basically, as I said before, they are massive computing facilities, right? So and they make use of ASIC, which is application specific integrated circuits, which are very high end computing resources, right? And the idea is that since the mining is a competitive process, so all the miners, they start mining once they have a couple of unconfirmed transactions, and they start mining, and the one who does it for the first, the one who does it first will actually broadcast the mine block to all the other miners in the node in the blockchain network, and then the block is set to be mined, right? And if everybody accepts, and if the miner who has mined the block first is not lying, and everybody has validated this newly created block, the one who has mined will get the rewards, right? So this is basically the job of the miner. But Lately, what has come up is these mining facilities, they have started collaborating with each other, and that's what is resulting in what is called as mining pools, right? So mining pools are is a concept where these individual miners, they start sharing their resources, to form a collectively massive hashing facility. And as a collaborative facility, when they mine a new block, then they will get the rewards, of course, right? And this reward is then shared based upon the proportion of how much computing facility was provided by any miner, right? So just for an example, if let's say there are 4 miners which have joined together, which have collaborated and formed a mining pool, then maybe first miner can put 10% of the total mining facility, other two can put like 25, and the rest can be put by the fourth one, right? So when the rewards are won, of course it has to be splitted in that proportion, right? And just to give you a glimpse of the mining pools that are there today, you can have a look on the picture towards the left of the screen. So here you can see, like, ant pool, and there are BTC top, BTC coin, and there are many more, right? And today you won't believe that the current hash rate has touched tens of millions of terahashes per second. So that's massive. Today it's maybe I would suggest you to if you get time, the participants of this FDP, to just go on YouTube and type the mining farms, and there are a lot of videos which will give you and glimpses of how these mining farms they look like. They are massive, and you will be able to hear the processing, the sound of these processors. It is so much of noise, and so much of intensive processing is housed in such mining farms, right? These mining pools are good, right? You are able to collaborate, and you can mine new block as per the requirement, and you get rewards. That is all good, but lately what has come up is an issue where people are saying that blockchain was created to have a decentralized system. Now if these miners, they all start collaborating with each other, and if let's say they have collaborated, and they kind of form a mining pool which is more than 51% of the total mining facility, then you can alter, actually you can mutate the blockchain, the entire database, because this is a democratic system, right? If more than 51% of the computing facility says that this is the current database, then everybody has to accept it, right? So this is kind of a bouncing back towards centrality if these mining pools, they start colluding, right? So think about it. It's a nice interesting research topic. People are working towards it, right? And also there are many countries which have now become the epicenter for mining and mining pools. The countries which are on the top list are probably China, and interestingly, Georgia is a very small country, but lately it has come up in this space. Of course, US and India is also there in the top list of countries which are doing doing a lot in this space, right? As mining and miner and mining pools. All right, so having said that, let me now talk about another interesting role, which is mining solution and equipment provider. So till now, in the last slide, we talked about miner and mining pools. They are actually the mining facilities, right, which are doing a lot of hashing and cryptographically computational intensive tasks, right? But another role, which is distinct from the mining pools or miners, are mining solutions and equipment providers, right? Here there are two type of paradigms that you can see. One is cloud mining and another one is mining as service, right? So cloud mining is a kind of a paradigm where if somebody wants to start participating as a miner without investing in the facility, right? Because if a customer wants to become a participant and and wants to start the mining, then it's a it needs a lot of capital investment, right? Because you need to house a massive computing facility, right? But here these cloud mining services are, they allow you to have an easy start, right? Which says that that based on your need, you can lease this mining facility, both the hardware as well as software from these cloud minings, right? Cloud miners, you can lease, and you can pay them. Of course, you can pay in a different way of, let's say, like how much electricity. So you leased, let's say, a certain portion of the computing facility, and then how much electricity was used, you can pay the electricity. You can also pay to this cloud mining in terms of percentage of the reward that you have earned by doing the mining. And also of course you need to pay at times the base fee, because if, let's say, you have leased and you are not able to mine any successful block, then you won't get any rewards. And if you don't get rewards, you won't be paying a percentage of that reward anyways, right? So base fees has to be there when you are making use of cloud mining, right? So here in cloud mining, the idea is that you kind of do not purchase anything. You simply go and lease based on your need the mining facility from these cloud miners, and then you pay based on what kind of an agreement has been established, right? However, on the other hand, there is a paradigm which is called as mining as service. Now, this is a different. Of course, at times there is a confusion here that probably it's the same thing, but there is a subtle difference between the two, right? So cloud mining. So mining as a service. This is a kind of a new business model that allows customers to purchase an ASIC miner. So here, customers are actually purchasing the mining facility, while this mining as a service company manages everything on behalf of the customer. For example, shipping, customs, custom clearance, and actual operation of the equipment and maintenance of the equipment, and ensuring that the facility is being used in an optimal way. So everything on behalf of the customer is actually, so expertise are actually called in by making use of this mining as a service facility, right? So the important thing to remember is the hardware is actually purchased by the customers here, right? However, such companies do not own the mining facility. So it is the customer who owns the facility. Mining as a service companies, they do not own the mining facility, but they manages everything on behalf of the customer who has bought the facility. All right. It's something like you own a farm, an agriculture field, but you just give it to someone to do all the kind of reaping of seeds and things like that, and then cropping of the yields and selling it, and you just get part of the profit, right? All right. So with this, so is it so far so fine? Am I audible? I mean, everything is working fine. Yes. Somebody can respond probably. Okay, fine. So, all right. So if so, then I'll continue. So another interesting role is called as ancillary service providers, right? So these ancillary service providers are the ones who are actually having different kind of roles, right? The first one is, for example, academies or the institutions who are taking the charge of educating and training people, right? So if you talk to the industry people, they would say that, of course, blockchain is very, very interesting. There is a lot of potential in the technology. It can change the face of industry and business operations. But the problem that they are facing today is that there is a lack of skilled people, right? Because there are numerous issues. If you think about the smart contracts, right? They have to be well written, so that all the aspects of the legal agreements are coded in that smart contracts. Because once it is deployed and once it is agreed upon, later on, if something is left out, or if the code is not exactly exactly representing those legal terms, then you can have problems, right? Also, there's a lot of dirt of, I would say, like a lot of need in this space to have engineers who can do like kind of at least monitoring, and who can do kind of integration of existing system with the blockchain system. So this kind of ancillary service, like institutes and academic organizations which are educating and training people, is very important, to support the entire blockchain ecosystem, right? So some of the companies, some of the organizations, or some of the players in this space are Blockchain Academy and Byte Academy, Consensus Academy, and Settlement, right? So Settlement provides ready-to-use tools that allow rapid, bringing of business processes over blockchain, right? Also, there are providers like which manages secure funding, and as I mentioned initially when started, the advantage of centralized system is that they have matured over the years. There is a proper legal framework and establishments which are existing, which help these centralized systems to work properly. But for decentralized autonomous organizations, you don't have till date, I mean, a legal framework. There is need to make sure that the proper legal frameworks are built and placed in that are placed so that they can support the such blockchainized system, I would say, right? So there is a kind of a need to ensure that the legal frameworks come and they kind of have compliance with the legal, the blockchainized systems are in compliance with such systems. But till date, it's an issue, right? Because there are a lot of issues I can discuss. Like for example, let's say there's a lot of emphasis given on privacy these days, right? So for example, GDPR law of Europe, or California privacy law, and India has also come up with its own privacy laws. So if I make a transaction in India, but it is passed to a miner which is located in, let's say, European Union, then the privacy law of this country is going to hold, or of European Union, because the transaction was actually confirmed there, which is located confirmed by a miner which is located in the European Union. So should privacy come as a design part, or also there is a problem like today, if you have a company running, let's say any XYZ company, then you have an hierarchical structure. There is somebody at the top position who is liable to all the legal responsibility, and he's holding the ownership, right? And this is hierarchical structure is there. So if there is anything wrong, then you can communicate with that authority. But in a decentralized organization, there's no person involved, or everything is so much automated that you find it difficult, like to whom to communicate if things goes wrong. So there are a lot of things. So such kind of services are very important, and these ancillary services, they support and they are very much required for the evolution of the blockchain ecosystem, right? And of course, connecting with experts is very important. As I said, that there's a lot of issue with the expertise which is required in such blockchainized system, right? So connecting with the right expertise can solve the problem in days instead of months, right? Yeah, towards the end, I would talk about a few more roles, which is blockchain alliance, right? So blockchain alliance, they are the ones who should do the kind of they should give a kind of a push to for blockchain technology to evolve, right? So their aim is to strengthen the collaboration between different stakeholders of the blockchain ecosystem, right? And there are different alliances, different alliance that exist. For example, R3, which is a big umbrella of Corda, and then there is Ethereum Enterprise Ethereum Alliance and Wall Street Blockchain Alliance, right? So their job is for the overall benefit, right, and for the wide adaptation of the technology. And somebody has to drive and make sure everything is working together, everybody is able to interact, and there's no friction, and every actor is able to gel with the other actor and to establish the framework. So this all role is of the blockchain alliance, right? So they share the responsibility like tracking legal issues and formulation of the standards, which is very much required. That would give confidence to business players to quickly adopt blockchain technology, right? And it also bridges the gap between various organizations and regulatory bodies. So there's a lot of things are converging, but there's still much to be done in this area, right? So yeah, I mean, things have to converge because there are regulatory bodies which are not that much kind of happy with that. Of course, there is a skepticism everywhere, but the regulatory bodies who wants things to be very transparent, and all this has to be done by these alliance. What I mean to say is, yeah. All right, so I think with this I will talk about now a very specific ecosystem. How much time do I have? Time check. I have time up to 1:15, right? If I'm correct. Can somebody help me with that? All right, so I think, am I audible? Okay, good. So somebody said yes. Thank you. So I think I have about 5 to 6 minutes more before I can wind up. So I'll talk about blockchain ecosystem for education, then a specific ecosystem, right? So right now I talked about the broad generic ecosystem, right? But this is once you are narrowing down to a particular domain, then you will have ecosystem for that particular domain and a specific area, right? So now blockchain ecosystem for education, this is one of our work which we have in 2020. We have proposed. So here you can see that there are different stakeholders, right? So since we are all connected with this education ecosystem, so there are different stakeholders here. Government as in regulatory authorities, they are there. Students are there. Companies as a recruiters, or as an internship providers, or as an R&D labs, they are there. Then there are professors, and there are schools and higher education institutes, right? They all need to fit in together, and they all need to put their processes on the blockchain system, right? I won't go into details of that because I think if it would be interesting to take up some questions, because if I start discussing this, probably I would need half an hour more. So I think I can quickly talk about it. So what the idea is, today the problem that we face is, the transcripts of the students are released by the institutes, right? So when a student is enrolled in an institute, under some program, let's say MBA or BTech or any other program for then the student has to undergo the program, and he has to appear for the mandatory requirement, for example, exams or PhD viva or whatever pre-synopsis and things like that, right? And once the transcript is released, the student gets a copy of it, right? And this when the student applies for a job in a company, then he gives he or she gives the copy of that transcript. Then the companies get that copy, and they in turn will verify with the school that whether these transcripts are correct or not. So it's a kind of a very cumbersome and time-consuming process that these transcripts are kind of they're issued, they come back, and for the students who have passed for, let's say, 5 years back, still the transcripts come to the institutes for verification, and this actually delays the overall process of sharing secure sharing of students' credentials, right? And also the frauds can be so I don't know whether you know it or not, but there is every now and then fraud being recorded in different countries about the fraud of degrees and the fraud institutes and things like that. So how to overcome this in a decentralized way, so that once the credential is issued, or once the school is within the blockchainized system, you are very much sure that this has to be, because this has to be an authentic institute, right? So this work, I think, talks about more on how to share and the credentials in a secure and a transparent way, right? All right. So I think with this I would stop here, and I thank you all for giving a patient hearing to what I said, and I hope you enjoyed. And now it's your turn to please give me some feedback so that we can have reciprocatory learning. Please, if there are any questions, I'll be happy to answer.
Participants, if you have any queries related to today's session, that is on blockchain ecosystem, you can post your queries in the chat box, or else you can unmute yourself and ask the resource person directly. Thank you.
Yeah, please feel free. I mean, I think I have about 3 to 4 minutes. We can make the best use of it. I mean, no question is, I would say, like, if I know the answer, I'll be able to answer it. Otherwise, I'll come back to you, or I can send after doing kind of research, because things are evolving in this space. So, is it possible to create our own blockchain or let me open up the chat box probably. So the question is it possible to create our own blockchain or private? Yes, of course, you can create your own blockchain. You can make use of Hyperledger Fabric, where you can kind of create your own blockchain. Yes, that's possible. Absolutely. Yeah. But these Ethereum, there are different platforms that you can make use of, right? So at times people, they want that they can, what they want is to create a decentralized application by making use of readily available APIs, application program interface, and quickly make a decentralized application which is having the power of blockchain technology. But of course, you can create your own blockchain also. I actually endeavored to do this with one of my students. Thank you.
For going for our own, our own blockchain, we require any license, or we have to pay any amount?
No, if you are going for a blockchain, a private blockchain, private blockchain has a different concept. So private blockchain is to be constructed within the group of, let's say there is a big MNC, and it has a different sectors and different I would say different domains. So they can create a private blockchain within their groups, or another instance could be, that one company which has a different sister concern companies, they can all put their business processes on the blockchain system. Here the miners need not to be given a rewards, because all are part of probably one big umbrella, right? So here, I mean, it's just a blockchain technology is just a big concept which makes use of many underlying technologies, right? So if you go for a private blockchain, of course you don't need anything, but if you're making use of blockchain infrastructure like Bitcoin or Ethereum, I mean, not talking about the Ethereum test networks and the Ethereum main network, then of course you will have to pay for every transaction that you're making.
Yes, sir. And sir, one more thing, sir. Sir, if possible, can you, in your second section, can you just practically show us how to go for our own blockchain, private blockchain, if it is possible?
So the second session tomorrow is planned for blockchain for COVID, right? So practically, I mean, I think it would need a 1 day to demonstrate and to do that. I think that would be a little intensive. Yeah. So I think that would fall beyond the scope, because if I go for that track of demonstrating, I mean, if that would have, I mean, if you could have, conveyed me before, probably we could have changed the topic itself, and taken up some more time.
Okay.
But yeah.
Sir, or else if you have any documentation related to that particular creation of blockchain.
So there is a lot of documentation which is available. I can also send you a couple of pointers, but I think, I mean, even if you just Google it, you will get a lot of documentation for Hyperledger Fabric and for Ethereum, and
Okay.
Most of the time, I think our requirement. I don't know, like from which perspective you are willing to ask this. I mean,
if it is practical, that means it is in the format of video, it will be good. I am, according to my requirement, that I am asking that if it will be in the format of a video, it will be easy for us to understand how to create a blockchain on private basis.
I think. Or
if you can suggest us any videos.
I'll think about it, like what to do. So maybe I'll share with you a couple of pointers where there's a good amount of documentation, and of course there must be a lot of online videos as well available. I'll share you with those resources, right? And I think I don't know, like from which perspective I mean people are asking, but I can also share some videos of the decentralized application which me and my students have developed. So tomorrow I can show a couple of videos of that of the decentralized application which we have created using blockchain system, right?
Yeah. Okay, sir. Thank you, sir.
Thank you very much. I enjoyed communicating with you, and
so one more question from Rajesh, sir. Where can we find guidelines for creating blockchain?
Where you can find guidelines for creating blockchain. So okay, so let me come back to you on this, and maybe I'll send you a couple of pointers where you can. But I think is it? See, I would say that. I mean, of course, it's very interesting and very, I would say, very, it's a very interesting question. But then we need to understand that actually, are we looking for creating the blockchain itself, or we are looking forward to create a decentralized application that meets our business requirements or any other requirement? So there are two entirely different things. Creating blockchain itself is like creating having an infrastructure facility, and then creating a softwareized or implementing algorithm so that the blockchain infrastructure starts working. Whereas creating decentralized application is making use of that infrastructure facility, blockchain infrastructure facility, and creating an application that serves your purpose. So there are two different things. So think about it like what exactly. Maybe you can drop me a message later today evening after discussing with Parchment, like what is the the real question. I mean, it's important to segregate what is our requirement, right?
Hello, sir.
Yeah.
So good afternoon, Anshuman.
Yeah, very good afternoon.
My name is Sanjeev Kumar Talari.
Yeah, hi Sanjeev.
So since yesterday, I'm just feeling that the entire concept revolving around Bitcoin and blockchain is totally focusing on open finance sector.
Okay.
Can we find any shift in that area in recent times?
So you mean to say any other domain in which blockchain has?
Like marketing and HR, like.
So yeah, I mean, if specifically you want to have an insight about marketing and HR, I can give you some insights to that as well. But believe me, blockchain has now outgrown from its inceptional use case, which is a cryptocurrency, which was Bitcoin, right? Today, yes. If you see, the use of blockchain has very much penetrated into supply chains, into education. There are universities like University of Nikova, probably, if I'm not pronouncing it wrong. So they are giving certificates of completion of course, that is blockchainized transcripts. Of course, there is a much of use of blockchain which is predicted for 6G, which I am working on. So for next generation of telecommunication, blockchain is one of the key technologies. So blockchain also for for medical, so healthcare sector, immense use of blockchain, because all that medical data which is being shared, it needs to be decentralized. It needs to have a privacy compliance also, and since because of this current pandemic COVID-19, you need to at times share securely this medical data, and not only among the states but among the across the borders as well, right? So that people can come up with research on more on that, and we can. So tomorrow I think I'll be talking about many use cases of blockchain to fight against COVID-19 pandemic. Now coming on to your specific question, which was HR and marketing. Yeah, so I am not a kind of MBA guy, so
actually,
I don't. So I'll try to give you. I think maybe you can later on help me with that. But I'll just give you some instances. Like for example, HR. I have dealt with of course when I am working, I deal with the human resource department, where I need to produce couple of documents, right? When I join a job or when I get relieved, I need to have a documents, that I was relieved from so and so date, or I joined this. So all these documents, normally they are all paper-based documents, and which can be very easily forged, right? Also, any document that you are transacting with any other department, right? It could be like HR dealing with marketing, HR with dealing with development centers. So everything that you are transacting, if you can bring it on top of blockchain, then there is no problem. Repeatedly asking whether this document was not forged, or so. It gives you kind of a secure alternate to paper-based document first, and then HR also needs to give me documents. So I need to produce document. HR needs to give me documents. Right? So all these documents, if they can be digitally signed and cryptographically sealed and put on the blockchain, then you can totally automate everything. In fact, also, I mean, it would be interesting. For example, HR wants to release a fund if you get a delivery of certain thing, right? I don't know, like finance department probably would do it, right? So you can put a smart contract at the time of the dealing with the vendors itself, that when you will give us that much goods delivery. Let's say you give us out of 10 goods, if you deliver 5, you the day you would deliver the 5th good, your 25% of the fund will be released to you. So everything can be automated and put on the smart contracts, right? And it gets triggered. You just have to someone as a user has to say that, okay, the 5th good has been received, and the smart contract gets triggered, right? Something like that.
Okay, Anshuman, thank you so much.
Yeah, welcome. I think I am exceeding with my time limit. I'm so sorry for that, and I think I'll now wrap up my session. Thank you, everyone, and thank you for giving a patient hearing. Have a good day.
Thank you, sir. Thank you for your wonderful session on blockchain ecosystem. We are looking forward. We are looking forward exactly for your next session, that is application of blockchain, because so many of our doubts will be answered in that session, it seems. Thank you, sir. Thank you for your wonderful session on blockchain ecosystem once again. Thank you, sir.
Thank you. Thank you. Pleasure is all mine. Thank you.
Yeah, participants. The next session will start at 2:10 p.m. So try to join by 2 p.m. itself, because the next resource person will also ready. Sir will join shortly by 2 o'clock. So the sir is going to talk about the same blockchain only, but different concepts. So the resource person is Dr. Mayank Agrawal, sir, from Manipal University, Jaipur. So please join in time. Thank you.